Hello Year 12 and welcome to the next episode of Mathematical Mowbray Movies. No new corny jokes for this video because we are continuing our work on the cosine rule. Of course you may want to renew your maths contract, but you'll love maths, you'll be awesome at it, you'll make up great maths jokes as inspired by me, and you will always say maths is the best subject. And again, a reminder of how this cosine rule fits in the big picture. Remember, we're dealing with triangles here, and in our case, triangles that are non-right angled triangles. And we said that we use the cosine rule when we're dealing with three sides and one angle. So let's have a look in a bit more detail. Last lesson we said that we can use the cosine rule to find a side. And when we were finding the side, we used this form of the cosine rule where the side was the subject of the equation. As I mentioned last video, you also get this other form of the cosine rule, which is just this one rearranged. Sorry, just this one rearranged. They've just swapped a few bits and pieces around, but they give it to you already rearranged, so you don't have to do it yourself on the formula sheet. So here's the form of the cosine rule rearranged so that this time the angle is the subject. Just like before, we have to remember that the C's are opposite one another. The angle C and the side C must be opposite one another. But the A and the B, it doesn't matter, they can be either side. But these two must be a pair. Again, the capital C, the one that comes after the cos, refers to the angle, and the little or the lowercase c refers to the side, and it's now over here in this particular formula. So let's get into an example and see how you go with it. So again, hopefully I'd look at this question and I'd see that there is 1, 2, 3 sides involved and one angle. So I'd see 3 sides, one angle, and my brain would say cosine rule. Once my brain has successfully said that, I then need to say, okay, am I working out a side or am I working out an angle? And I can see here that I'm working out an angle. And if I'm working out an angle, I use the form of the cosine rule that looks like this. Again, given to you on your formula sheet, so don't worry about remembering it. Just be careful about where the adding, addition and subtraction goes, because people get confused with that sometimes. Then it's just a matter of, again, working out your pairs, your C pairs, and then substituting into the equation. So I look at this diagram and I can see pretty clearly that this is my pairing, my angle and its opposite side. This is going to be my capital C then. This is my lowercase c. A and B, remember we said it does not matter one little bit where you put them. Either side is fine. Then we substitute into our equation. Theta is what I'm trying to find, and that's given by the capital C. So this is going to be cos of theta equals, I substitute in what I know. A is 9, B is 12, C here is 6. I'm putting in all those squares, of course. And then I'm dividing by 2 and times by A. Remember there's little multiplications in between these letters. So 2 times by A is 9, times by B is 12. I'm going to whack that into my calculator here. So I've got, and you guys I know often like to set it up with the fraction. This calculator is a bit funny with its fraction button, so I'm just going to do it the old school way and put it all in brackets so it doesn't mess it up. And then I'm dividing by 2 times 9 times 12. You guys, of course, will do it your way. This gives me 0.875. And remember, at this point, I've just worked out what cos theta is. I need to work out what theta is. So I have to use the inverse operation. How do I get rid of cos? I do the inverse of cos, or cos to the minus 1. So to bring this away or get it off this side, I do cos to the minus 1 of 0.875. So I'm just going to go inverse cos, and I like using a little answer button because that recalls the last answer that I had, saves me typing it all out. And this is 28.955 degrees. Now sometimes, of course, you know, you're asked to put your answer into degrees, minutes and seconds, I think. This calculator, I need to press that. So this tells me it's 28 degrees, and I would round this 57 degrees. I'd round it, I'd just keep it as 57 degrees because the next bit's 18 minutes. So this is going to be 28 degrees, 57 minutes. Or that would actually round, if I wanted to the nearest degree, it'd round to 29 degrees, since this is very close to 60, and there's 60 minutes in a degree. Okay, so now of course it's your turn. Oh, I forgot to say, this is your turn. So give this particular question a go. Here, your turn. Have a good time. Good luck with this particular one. All right, let's see how you've gone with this particular question. It says triangle ABC is an isosceles triangle. That means two sides are equal, where the length of AB is the same as the length of AC. Well, I can see that. It says AB is 3 metres long, which of course means that AC must also be 3 metres long. It says if BC is 2 metres long, so there's BC, 2 metres long, it asks me to calculate the size of angle BAC. So it's asking me to calculate the size of this angle here. So you've got to be able to get that information onto the diagram. Again, I say to myself, okay, this is a non-right angled triangle, so I'm going to have to use the sine or cosine rule. I say I've got 3 sides and 1 angle that I'm dealing with. 3 sides, 1 angle means cosine rule. So then I have to say to myself, am I trying to calculate a side or an angle? I'm calculating an angle, so I'm going to use the form of the cosine rule off my formula sheet. That looks like this. I have to work out that these two are my pairs. This is going to be my capital C, this will be my lowercase c. A and B, of course, as we've said, doesn't matter what side you want. Substitute everything in. My theta is what I'm trying to work out here. Oh, sorry, that should have been a C, but you know what I mean. So theta is what I'm trying to find. A squared here is 3. B squared here is 3. C squared here, I've got 2. Of course, all the squares. I'm dividing by 2 lots of A, remember the multiplications, and B. Whack it into my calculator. Remember, you can set it up as the fraction if you want. I tend to do it this way just because I'm a little bit old school, in case you haven't noticed. Divided by, and 2 times 3 times 3 gives me 0.77, and it's of course recurring. I don't want to find cos theta though, I want to find what theta is. So here I'm still at cos theta. I just want theta. I have to get rid of that. Taking it to the other side, I use the inverse operation. So remember, that's cos to the minus 1 of 0.77 recurring. I would, again, do the same thing as I did before. So I would use the inverse cos, and I just use my answer button, so I don't have to type it all in again. Gives me 38.94 degrees. If I want that, remember it's an angle, that's why I've got the degrees. If I want it in degrees, minutes and seconds, this would be 38 degrees. This will actually round up to 57 minutes, since this is over halfway. Remember, it's 30 is the halfway point for degrees, minutes and seconds. So this is going to round to 38 degrees and 57 minutes. Okay, hopefully you got that one right. Here is the last one, and it's a little bit tricky and it'll take me a little while to go through with you. So I'll get you to have a go at it first. It's probably a little bit hard to see there, isn't it? Sorry, let me just zoom that in a bit. Okay, there's a question for you to have a go at yourself. Why don't you try part 1 and then check your answer. I'll show you how to do it, and then try part 2. So have a quick go at part 1. All right, let's have a look at part 1 before we do part 2. So it says, show that the length PC, so the length PC, so it's this dotted line, is 6.197 metres, correct to 3 decimal places. So I would look at this and I can see really clearly that there's some triangles going on there. So I would redraw this triangle for myself. I'd be looking at it and going, okay, here's the triangle. It's pretty average drawing, sorry. What information do I know? I know that in this triangle, this length is 5.4 metres. I know that this length is 1.8 metres. I know I'm trying to find this length, PC, and I know that this angle is 108 degrees. So straight away, I'd look at this diagram and I'd go, 1, 2, 3 sides and one angle. What do I need to use? I need to use the cosine rule. So here I'd say, okay, what am I trying to work out? I'm trying to work out a side. So in this particular case, and I should have told you that this one wasn't necessarily working out an angle, but in this particular case, I'm going to use the form of the rule that has the side as the subject. So I'm actually going to use this form of the rule from the last video. Where's my pair? These two here. So I'm going to say that c squared, notice this is only worth 1 mark, so you've got to be able to nail these ones. So I'm going to say my c squared is my x squared. A and b, remember it doesn't matter. 5.4 squared plus 1.8 squared minus 2 times 5.4 times 1.8 times cos of my angle was 108 degrees. Remember, I want to find x rather than x squared. So this is going to be the square root of all of that. 5.4 squared plus 1.8 squared minus 2 times 5.4 times 1.8 times cos 108. Whack it into your calculator. Hopefully it spits out that number that you're after. So the square root of 5.4 squared plus 1.8 squared minus 2 times 5.4 times 1.8 times cos 108. Close my brackets, gives me not the answer that I wanted, so we may need to have another quick look at it. Did I type in something wrong, you guys? Let me try again. The square root of, I've got all these numbers right, haven't I? 1.8, 108, trying to find the length PC. Yep, let's try again. Might have just typed something in wrong. So the square root of, I open my brackets, a squared, 5.4 squared plus b squared minus 2 times a times b, did I press plus last time? Maybe I did, times b times cos 108, close my brackets, equals 6.197. Who knows what I did wrong last time? You guys might have seen. 6.197. That's why it's good to check your answers. So I've shown that x is equal to 6.197. So in my diagram, I've shown that PC, this part here, is equal to 6.197. Okay, now it asks me to calculate h, the height of the object above the ground. I'm actually just going to fold this over and get a new piece of paper. Now you can see, or you probably can't see because I just moved it out of the picture, that this question is worth 4 marks. It's a tough question, okay, but if you're wanting a band 5 or 6, you're going to have to be able to access that. So, your turn first, give it a go and see how you go. Alright, let's have a look at how you went. As I said, this is a tricky question. It's worth 4 marks, so it requires you being able to see a few steps ahead and to work with those bits and pieces. So, it's a little bit tricky to get all this into page, isn't it? I'm just going to put this here so that we can see. Remember, we're trying to calculate here the height h. We're trying to calculate this part here. And I've got all these bits of information. What do I know? I know that this is a right angle. Okay, I know that if I'm trying to calculate this little bit h, I'm going to need to know this full height. So I'm going to need to know this full height, and then I'm going to take away the 2.1. So I'm going to need to get this bit first. Now, if I want to get this bit here, I'm going to need to know something else in this triangle. Let me draw that right angle triangle for you. So this is P, C, and E. So if I'm trying to find that full height there, so this is this full height here, and I know that this one is 6.197, that's not enough information for me yet. I either need to know this side, and then I'd use Pythagoras' theorem, or I'm going to need to know one of these two angles. So either of those is a fine option to use. It doesn't matter particularly which one of those two things you use, but you do need to be able to work that out. I'd look at it and think, okay, there's no really obvious way for me in this diagram to work out this side length. So I think I'm going to have to work out one of these two angles. And this is why this question's worth 4 marks, because there's lots of thinking involved. So I say to myself, how am I going to work out one of these two angles? Well, to work that out, I'm actually going to need to use some of the information from my previous triangle, so from that non-right angle one again. So let me draw up that non-right angle one again for us to work with. So it's here. If you've given up on this question, then that's okay, but if you're after a 5 or 6, you're going to need to stick with these questions, persevere with these tough ones. I know that this is 108. I know that this is 5.4. I know that this is 1.8. I know that this is 6.197. Is working out one of these two angles, that is this one or this one, is that going to help me to find either of the angles in this right angle triangle? Well, yes it is, and it can be a little bit hard to see. But if I can work out this angle, I can use that alternate angles rule, the Z rule here, to say that that angle is going to be the same. So since this line and this line are parallel, this angle and this angle will be the same. So I'm going to work out what this angle is. That's then going to give me this angle. Then I'll be using SOHCAHTOA. But you can see there's a lot involved here. So how am I going to work out this angle here? That's the next thing I've got to look at. Well, I've got a couple of different options that I could use. So I can look at this triangle and say, well, I know 3 sides and I'm dealing with 2 angles. So it's 3 sides and 2 angles. So in fact, I could use either the cosine rule or I could use the sine rule. Neither of those is better or worse than the other. Since this video has been about the cosine rule, that's what I'm going to use. So I'm trying to find this angle, and so I need the opposite side pair, where this is going to be my C, my capital C. This is my lowercase c. These are my A and B. Doesn't matter which way they are around. I'm finding an angle, so I'm going to use the form of the rule that looks like this. A squared plus B squared minus cos C equals A squared plus B squared minus C squared over 2AB. Substitute in. So I'm trying to find cos of C. My A here I just said was 6.197 squared. My B squared I just made 1.8 squared. My C squared is 5.4 squared. I'm dividing by 2 lots of. A is 6.197 and B is 1.8. So let's whack that into our calculator. You can see that there's lots of steps involved, but this is the reality if you're trying to get these high bands. So 6.197 squared plus 1.8 squared, you probably can't quite see what I'm doing here. And I'm minusing 5.4 squared, closing my brackets, and I'm dividing that by 2 times 6.197 times 1.8. Close my brackets, gives me 0.5595. And of course that's cos C. I just want C, the angle on its own. So I have to do the inverse cos to work out C on its own. So I use my inverse button and I just press my answer button. That tells me that this side length here, this angle here, not side length, is 55 degrees and 98.98 if I round it. Of course I could put it in degrees, minutes and seconds. 55 degrees, it actually rounds to 59 minutes because this is at 34. Okay, so either of those is fine. Now, it's easy to lose track of where you're up to with these questions and where you're trying to get to. But remember, this is now this angle here that I've worked out. And remember, we just said before in our diagram, I know we keep sort of scooting between one and the other, that I've worked out this angle now and it's the same as that one. Or that this angle here is the same as, this angle here is the same as this one. So I now know that this angle is 55 degrees and 59 minutes. Now, and you can see this question's got a bit of everything in it, this is a right angle triangle. So right angle triangle, I've got two sides and an angle. I can breathe a sigh of relief. This is just an old SOHCAHTOA question. Nothing too complex. Here's my angle. This side is adjacent to it. This is my hypotenuse. So this is my adjacent side. This is my hypotenuse. So I'm going to be using the ka bit. Cos. I write out my rule. Cos theta equals adjacent over hypotenuse. I plug in what I know. I'm trying to work out my x, so I plug in cos theta was my angle, 55 degrees, 59 minutes equals my adjacent side was x. My hypotenuse was, my hypotenuse was 6.197. I'm trying to work out x. Remember, when this is on the bottom, you bring it up and times, no switcheroo, you just bring it up. So this is going to be 6.197 times cos of 55 degrees, 59 minutes. You can put that in brackets if you want. Will give me x, and I can breathe a sigh of relief because I'm finally at the point where I can give myself an answer. So I'm going to go through and type that in. So 6.197 multiplied by cos of, and you can put in your brackets if you want, 55 degrees and 59 minutes, close your brackets, equals 3.4, what's it say, 3.4668, so I'm going to write all that, is x. Of course, that's not even quite my full answer, so I've just worked out this full side now to be 3.4668. I'm after this little bit here, h, so I'm after this bit here. I know that this is 2.1, so this has got to make up the difference. So my final step here is that h is going to be equal to 3.4668, take away the 2.1, which gives me 1.3668. All right, and of course it's in metres, I think. If you got to that answer, congratulations, you're tracking right toward a Band 6 there, because that's a really tough question. It's question 30 in the HSC paper, and so it's right at the end. It's meant to be tough. It's worth 4 marks. It's meant to be hard, so well done. If you got part way, congratulations. It's out of 4, and so if you got 1 or 2, you've done very well there. If you gave up before you started, then maybe give it a bit more of a go next time and be a little bit more resilient. That takes you to the end of the cosine rule. Congratulations, you guys.